Welcome to Command Shift Left, the podcast that helps you navigate the treacherous waters of the software development, ops, and security world while also diving into the hot current trends in the industry. Join myself, developer Philip, our co-host Orvice.
Hey audience!
As we battle through hilarious real-world stories, pro tips and hacks for navigating your way around developer security, learning about our Shift Left life, and life stories that have saved our ass. We have an absolute pleasure of hosting two awesome guests of us today. We have Austin and Corey. Why don't you guys introduce yourself very briefly, and let's start with Austin.
Hi, everyone. My name's Austin Parker. I'm head of developer relations at Lightstep, a ServiceNow company. I'm a maintainer of the OpenTelemetry project and author on all matters of observability, and I did a DevOps conference in Animal Crossing one time.
Sounds great. And you, Corey?
Yes, I work at a direct competitor called Stomp, the exact opposite of whatever a Lightstep might be. I kid. I am a chief cloud economist over at the Duckbill Group, where we fix the horrifying AWS bills. I also write Last Week in AWS, a newsletter podcast combination that makes fun of AWS because I have personality problems and am extremely annoying. I also periodically host the Screaming in the Cloud interview show, which is neither here nor there.
Awesome. So, sounds like an absolute blast. And without any particular order, let's move on to our first fact, which I heard Austin has for us.
Yes, my strange fact, but true, is that 99% of your logs are useless.
Very controversial.
Ooh.
99%.
Oh, yeah, 99.
What does that actually mean? Like, what's left? What is valuable?
1%.
It means nobody visits his website, and therefore that 99% is just load balancer health checks.
The 1% is the 1% that AWS can charge you for.
Oh, that shows a certain lack of imagination now, doesn't it?
I mean, I'm not the one coming up with their pricing, so...
No, I wonder often who does that.
I'm highly imaginative, but not quite that imaginative.
Yeah. When accountants get creative.
Oh, that sounds like a horror movie, not a comedy podcast.
Sounds like how I went to prison. Yeah.
I think that's the line, isn't it? Right? Like this is my grand plan to free us all from the tyranny of crypto people, is to basically give them PvP enabled finance, where if you've ever been convicted for securities fraud, you get to go do crypto stuff forever, and then the only way to get in there is to commit securities fraud. But that's a nice way to kind of select people out, right? No rules, cool, here you go. But on
the original
onto a topic that'll probably piss off fewer people. No, I mean, but think about it, right? Like most of the time that you have anything that you're building, most of your logs are going to be completely unremarked upon. Mm-hmm. They're completely worthless. You're going to be sitting there, they're scrolling, they're costing you money. You're writing it out because that's all you know how to do. That's the only way that you can introspect the behavior of your application, is to do, a bunch of effectively console.log. But most of them have zero purpose and only serve to give you a baseline that the 1%, the things that actually are helpful, that help you figure out like why is it crashing, or why can't Aunt Velma in Topeka access, my greeting card site, like that 1%, incredibly useful. In fact, you can't even put a number on it because it's so valuable, which means that we effectively are paying for the 99% of useless logs in the hope that we get that 1% of useful logs.
How can you differentiate between those, then 1% and 99%? Like if I want to improve my logs just by cherry picking them better.
Do you want the joke answer or the real answer?
I want them both,
they
obviously.
Might be both. Okay. I mean, the joke answer is you pay someone else to do it for you, which is also the real answer. But no, to be a little more precise, the only way that you really fix this is through correlating telemetry, right? Like the problem that we tend to fall into is that logging is a very blunt instrument. It's the only way that you, for many things, it's the only way you have any ability to introspect the behavior of what's happening, especially in a distributed system. What you need to do is you need to combine those logs with other forms of telemetry and use those other forms of telemetry to help you kind of narrow down and identify, where is the need, what is the 1% of this this entire set that's actually useful. Once you have things that can do that correlation, right? Once you can kind of link these different signals together and not think of them as just like, I have a big pipeline of logs over here and I have a pipeline of metrics over there and a pipeline of traces over here, then you can start to talk about, okay, now let's use this data to build on itself, right? We can use our metrics to kind of help train our sampling pipelines on what logs are useful, which ones aren't. You can also use different types of data, right? Like I mentioned, metrics, traces, and logs. Some of you might think of those or have heard of those as the 3 pillars of observability. This is a lie. There's no such thing, and you should not think about them that way.
Observability is just a scam.
I think they would probably get mad if I said that.
Probably.
But observability is not telemetry.
Right.
They will not get mad if I say that. And having a bunch of different signals all put together does not give you observability. It's the furthest thing from it. So what you have to do is you need to have those signals, yes. Then you need to combine them in ways that let you use one signal to understand where on this other one I should go get, or should go start looking. I think Corey had a point too, yeah.
Yeah.
I'm wondering how much of this applies to the old world way of thinking about logs versus the way that a lot of logs are manifesting these days in a more structured / enriched format. Amazon internally and publicly talk about their EMF, their embedded metric format, where effectively they replace all of their logging calls with print statements that wind up showing up in logs. And that way, first off, if you're just sending this stuff into CloudWatch, for example, they talk about this as a cost savings. I love it when a company incidentally talks about, here's how you save money with our ridiculous pricing models. But great. More to the point, though, it lets you extract metrics down from logging data. And as we talk about different pillars of observability, okay, great, we can use words all we want, but what I wind up discovering an awful lot when digging into it, that traces are effectively just log messages that we trace throughout the course of what's going on. Events are logs, effectively, and metrics, for many respects, are just, okay, the number of time we see this thing in the logs. It really does feel like it all comes down to logs.
It does. And I mean, you've hit on an important point, right? These signals are all effectively convertible from one to another. A trace, is nothing more than a log with a defined schema and some sort of context instrument that gets passed from hop to hop to hop in my distributed system. Now, I don't want to minimize it by saying, well, it's just that, because there's a lot of actual advantages to do those conversions. A metric that I create by looking at a stream of CloudWatch logs is much cheaper to preserve for 24 months than the raw text of all those log messages, for example, right? Conversely, I can also, again, use this sort of filtering and sampling stuff. So I can say, well, take all of these logs and turn them into metrics, and that costs some amount of money, but certainly less than storing all those logs for a year. But now, if I see a log that says error or has some other thing that seems important, keep that one in full, but throw all these other ones that don't have an error away. And that lets me use these multiple signals to help understand, like, what is the useful 1% of my logging.
But going back to the 99% of logs that are essentially useless, why would we need mechanisms like filtering? Why not just get rid of them, essentially, and just provide the ones that we will actually find useful? It'll definitely stop us searching for thousands of lines of code and save us time.
That's
right?
True. I think if you solve the halting problem, you can probably apply that to much better things than determining which logs you should keep and throw away.
Joke's on you. The Lambdas already have. Great. 15 minutes, your code will stop. The end.
Right. And if we solve that, then we've solved, then world peace is right around the corner. So I think that we need to, people tend to, I feel like, focus on the end of the story a lot. You'll see people when they talk about logging, they talk about observability, they get very caught up in sort of things that are secondary to the observability, right? They think about, like, how am I going to store this data? How am I going to process this data? How am I going to filter it? And they don't ask the questions of, like, well, what am I actually trying to do here? Like, I'm collecting reams of analytics, performance analytics about, my software in prod. I'm collecting a ridiculous amount of user analytics. I'm collecting all this business data. And having that data by itself does not give you observability. It doesn't actually give you any greater insight into your system than if you were just kind of making blind guesses. It just means that you now have the condition, one of the conditions, to start asking those questions and to start thinking about your system in these holistic ways. So that, I think, is really the thing to flip, right? If you start thinking about it from the perspective of, I have a bunch of, the data itself is not the observability, or to take a different, to pull a different quote, the map is not the territory, right?
Mm-hmm.
What you think is there and what is actually there and what you're actually doing with that stuff, figuring out that where you're trying to go makes a lot more sense and is going to help you understand, like, okay, well, what signals do I actually need? How am I able to actually kind of use that data to feed into itself and go on and on and on, rather than spending a lot of time figuring out, like, oh, this is the cool, database stuff I need to do, or I need to scale out all these, Prometheuses or open searches or, dogs.
I feel like there's a new buzzword coming in here, like intent-driven observability or something like that.
We don't have enough things that blank hyphen-driven observability or development. There's surfeit of those.
Yeah, it could be more overwhelming, the space. I definitely think so.
Well, think of all the value we could create for investors if we just kept adding more and more finely sliced, observability startups.
The new hype's the exact opposite direction. It's called observerless.
Ooh, I love that.
I think, if you remove the engineer from the equation, a lot of the friction is just out the window immediately.
I think we can go a step further. They talk about low code. Well, what about no code? If there's no code and there's no application, then there's
literally no code.
You don't need any observability. Or actually, I should rephrase that. You have perfect observability. You know exactly what a no code application is doing.
Sometimes the only purpose of logs is so you can get blamed after the fact.
Blame driven development. That's a good one.
Oh, yes, or avoidance of same.
Mean time to innocence.
Till proven guilty.
Find me a single CISO who's not ablative. There's an outage, there's a breach, they wind up getting ejected and they get burned through.
I saw a very funny
Risk of the
story
profession.
about that. But
I think this might be a good spot to move to our next fact. And the next fact, the second fact for our episode is mine. And the fact is, your APIs are more and more invoked by someone else's APIs.
Oh, God.
So to explain, as time progresses and applications become more complex, they use other applications. So APIs are mostly used by other APIs, which in turn are used by other APIs, and it's kind of APIs all the way down. And the argument here is kind of similar to the simulation hypothesis, which I've promised to recap from another episode, so referencing our previous one. So quickly on the simulation hypothesis, the argument goes, assuming some civilization somewhere decides to create simulations, it's more than likely that within that simulation, a civilization would decide to create a simulation. And then within that simulation, another simulation, with that simulation, another simulation. So it's simulations all the way down.
Is this another recursive joke?
Everything is recursive in life. It is. And then because
you'll find it really tells itself.
Quite so. And then you find that because there are a lot more simulations than baseline realities, there's only one baseline reality, but potentially infinite amount of simulations, we are most likely within a simulation, which I think will definitely explain this conversation, if not anything else.
Yeah, no, we can. I think there is a good primary source on this. For living in an endless chain of simulations where your actions don't seem to have any effect on the true reality, but you continue to progress no matter what. And I think we could just find someone that works at IBM and ask them.
Oh,
low blow.
No, I love what they've done for the open source community by continuing to subsidize our friends at Red Hat.
Yeah.
Think about all the people who work with Kubernetes that would be denied the joy of writing YAML for the rest of their lives without Kubernetes.
So it's IBM's fault is what you're saying.
Yeah. I kind of want to go back to my baseline fact and get your insights on that. So a lot of times as a developer, when you're building software, you're thinking about your end customer who will be using it. That it might be a developer who uses it as an API, but you're thinking about usually a human person interacting with it. How do you think it changes when you should probably imagine someone else's software devoid of emotion and carrying of value, just using yours and being used recursively by more such software.
I'm reminded of a meme about the Chad web scraper.
I think the problem with this is that increasingly, you're right, is being called by an API, and that API increasingly looks like whatever browser you happen to be using with its own interpretation of how things work. The question between a human and an API is starting to become almost academic in some cases. For example, okay, great, you get in the CORS headers you'd expect to see, but how those are interpreted and displayed become very different depending upon how well you are modeling what the browser engine is doing. Similar stories exist with HSTS and other browser-based behaviors that are effectively transparent unless you know where they're there and go looking for them.
And I would say the real distinction is less. Humans have flexible expectations, right? Like, if I'm using, here's a good example from my real life. I am a big fan of placing grocery orders through an app on my phone, right? Like shout out to Hannaford, my local grocery, my regional grocery chain. Love them. But I go into the Hannaford app and I make my order.
Shout out to Moishe, my grocery man.
Yeah, everyone get your grocery
Hannaford
grocery
is
chains.
headquartered in Scarborough, Maine, where I grew up.
Yeah. And then you wound up in the West Coast somehow. Anyway.
As far as I could get without a passport or a boat, yes.
That's why I always say what I love about California. So all the weirdos go and then they stop because there's an ocean in the way.
Exactly. It's cold and dark 9 months out of the year. All you can do is sit inside and become weird.
Doesn't say that I'm still in New York. Anyway, love the Hannaford app though. Go through every Sunday, make my order for the week, eggs, milk, bread, whatever.
Mm-hmm.
And sometimes the performance of this application is absolutely god awful. I'm sorry, Hannaford, but
he gives and he takes.
It's literally you tap on something and it takes multiple seconds. Some weeks it's fine though, right? But I have a thing that I obviously need to accomplish, which is ordering groceries. And two, I am a human being and I can tolerate a high variability in response times. So even from clicked interaction to interaction to interaction, it might frustrate me, but it doesn't, make me completely shut down and devolve into tears. Whereas as a machine,
I don't think an API would shut down. Like, you can retry.
You can retry, but here's the thing. My tolerance is variable. A machine's tolerance usually isn't, either implicitly or explicitly, right? And so the more that your API and the more that your software becomes part of an implicit distributed system being called by other machines, then their expectations are also now being baked into your performance. And this is one of the reasons that I think we talk to people about SLOs, right? And setting SLOs and being able to say, look, here's the actual acceptable range of outcomes for our API or for whatever we're doing, and enforcing that so that people don't become reliant on a higher quality or higher level of service than we're actually going to provide in most circumstances.
What about machine learning agents like ChatGPT? Once it becomes fully internet enabled and goes full Skynet, probably the second step.
Well, I'll be personally disappointed because I had thought for a long time that, my real value was sounding very confident about things that I was completely wrong about, but ChatGPT has really weaponized that.
It's coming for our jobs, yeah.
Yeah, so Corey and I are going to be just like panhandling outside the Salesforce Tower or something within the next 20 years because of it.
Along with disturbing a portion of the current Salesforce employees, but that's neither here nor there.
Yeah, that's neither here nor there. But hey, maybe if we're lucky, the transit center won't collapse on us.
We can dream.
What about the API usage by such agents? So you talked about like just your run-of-the-mill, I guess, back-end application interacting with yours. What about slightly more sophisticated agents using APIs?
I mean, you already see like if getting into anything involving like machine learning or LLMs or diffusion-based image models like takes you into a whole different area of horrible things going wrong. But I think as an example of the interesting consequences of poor API performance is over the weekend, there's a Twitch channel that has created a infinite machine learning based Seinfeld episode, and it's feeding AI input. It's feeding GPT outputs, OpenAI's LLM inputs back on itself to create little skits and jokes and doing all this through the power of machine learning. And it got banned over the weekend because of a API failure. It had to fall back on an older model that did not have some of the protections against content.
Oh no!
And so suddenly the machine AI started spitting out, inappropriate humor, and so the channel got banned for it for 15 days or whatever. So I think this is mostly a.
And did they find out why there was a failure for a specific API?
Did they have the right logs?
It wasn't complex enough.
No, I'm sure it was complex to the OpenAI people, but this is like a third party, right? This is a consumer of of OpenAI's APIs that wound up facing the consequences of, a downstream dependency. And I think that's, existentially terrifying in ways that many, complex human-machine interaction model failures aren't. But I would also point out that there's a non-zero amount of people that have died due to, I don't know, their Tesla deciding that the side of a semi-truck was actually the road. So,
my goodness.
Sometimes humans do that same thing. So
exactly. And now we can offload the really difficult task of like killing ourselves through machinery to a computer. I'm making a lot of friends this episode.
What I kind of like about this is the hints of the singularity, I feel like, are coming in. Like, everything is becoming more interconnected. It's more applications built by other applications, being used by other applications, and the pace in which they're being interconnected is accelerating. So it kind of feels like the future that we've been warned on or promised, depends on your perspective, is right around the corner. And I personally can't wait to be uploaded to the cloud and be stored in an S3 bucket. And due to billing reasons, probably having to erase my grandmother's memories so I can afford to stay up.
And I'll be one that will go in and purchase that memory and just download it into myself and feel what it's like to be your.
So that's I was only selling the memories of my grandmother, so you only get to experience that. But yeah, maybe that's their true business model behind AWS.
That's hilariously dystopian.
Sounds scary, but let's not go into that alley because it gets much scarier than that. Anyway, I'd love to hear what fact Corey has prepared for us, because apparently it's something special.
I was not told there would be assignments on this. Oh, I've got something special. It's always great. Now, there are a few things I could go with here. You could talk about how, I don't know, everything's a database if you hold it wrong, which is true and basically uncontroversial. There's the reality, which is also provably non-controversial, which is that your AWS bill is not a function of how many customers you have. It is a function of how many engineers you hire. And that is a depressingly accurate fact. But instead, I'm going to go with something that I've been meaning to talk about in public for a little while now, which we've been internally calling this Quinn's Law for a while now, which is, and it states quite simply that the cloudier your application or environment becomes, the less expensive it becomes, but also the harder it is to predict what it costs. And an example of this is on one end of the spectrum, you've got a data center. I'm going to build that out to host an application. And it's going to cost a mountain of money, but I can tell you almost to the penny what that's going to cost for the next decade. Whereas if you go with the cloudiest imaginable thing, not to be confused with cloud native, which is a term that has been interpreted to mean, whatever it is we're trying to sell you, that's cloud native. You have these companies saying, oh yes, we're cloud.
I was wondering what it means.
You have these giant companies like IBM and whatnot. Oh yes, we're cloud native. And they speak with a heavy data center accent about the old environment. And they're effectively drinking storage appliance borscht as they go. But great. Here in reality, it's like they're cloud immigrants, which is, again, not trying to be politically charged, but that is what they are. But if you're talking the cloudiest environment possible, something pure serverless, and I mean real serverless that scales to zero, not something that doesn't, that Amazon slapped a serverless logo onto because they didn't realize that words mean things anymore. And you wind up building it, something that's only charges per usage. Well, you have no idea what it's going to cost. The only way you can figure that out is as a derivative of some other business metric. The number of customers we have, the monthly active users, daily active users, et cetera, whatever it is that someone else drives, which is a beautiful punt to someone else in the business planning meeting. It's, well, over to you, Stephen, because everyone hates Stephen. Yeah, how many users are we going to have 13 months from now? and everyone's back in the land of guessing.
And is that a problem or an opportunity, what do you think, for businesses?
That's the fun part, because it depends entirely on the context that the business has. Because for you or me, where I want to spend the actual least amount of money possible out of the company to run this thing, which is, a logical framing, then I think it's great news. The problem is that many businesses bias, in some cases uncomfortably so, toward wanting to spend more money in order to be able to predict what that money is going to cost. The ultimate example of this is, frankly, the federal government, where Uncle Sam will gladly spend $10,000 to make sure that he gets his 50 cents in tax on something. And the incentives, I'm not saying that any of these people are irrational actors. They're not.
Mm-hmm.
They're responding to the incentives that they have. They're constrained.
Within their context frame.
Exactly. They have their own constraints that shape what they do. Their context shapes them. But man, is it challenging when you have people on opposite sides of that context divide trying to meet in the middle.
Yep.
So how do we go about tackling that?
To what you were saying, though, about like the CapEx versus OpEx thing makes perfect sense, though, right? Like, capital expenditures are hard. They're hard to not hard to amateurize, but they're hard to actually like put in the balance sheet because you have to make the numbers work, right? You're trading out flexible money for inflexible money. And for the past decade, maybe that was a bad trade because you had much like the federal government, effectively an infinite free money fountain. Again, not to be political, but that's effectively how it worked. Sure would be a shame if there was some sort of, I don't know, macroeconomic situation that changed that was entirely foreseeable, like interest rates rising. But, and that's where the twist flops, right? And we get back into actually, maybe the way we've always did things wasn't so bad after all situation that we find ourselves in.
Remember, psychology weighs into this a lot more than actual logic or arithmetic do.
Yeah.
And part of the challenge is that if I'm building out that data center, there's a whole bunch of vendors that are involved. I'm amortizing capital expenditures across a decade in some cases for the physical plant. I'm buying servers that I then can do on corporate leasing. I could play all kinds of games with that. If I'm putting this all through my AWS bill, I've got a single line item that shows up every month in an invoice that looks suspiciously like a telephone number going by number of commas in it. And wait, what the hell kind of comma? What kind of phone number has commas in it? Yeah, apparently you don't call big companies anymore that have giant extensions that look like a dump of their firmware. I digress. But it becomes this one company, this giant expensive thing. So like, great, how do we reduce that amount of money? Usually second only to payroll and occasionally the real estate budget if you have a physical office plant. And the answer is well, it's not a finance question, it's an engineering question, and the answer is complicated. So the easier answer is, okay, we're going to do layoffs instead because that's a shitload easier for us to wind up wrapping our heads around. And they're not wrong given the insight and constraints that they have. Companies that I talk to that are spending significant levels of investment on reducing their AWS bill are still spending more than they were earlier. In some cases because they're doing it more efficiently and they're growing, and that's okay. And in other cases because it's hard to drive cultural change. To address the question that was cut off, how do you do about it? Mm-hmm. I don't know. I don't know how you fix these things, because if I knew how to fix corporate culture and change that, I would be in a radically different line of business. It's rare that you see a company change culture at all.
But you said it's an engineering problem.
Oh, it is. It very much is.
So if I'm a individual contributor, an engineer, and I'm starting to hear that buzz, especially in the current economic climate, and I'm hearing about trying to save a few bucks or layoffs are going to be coming, what should I do? What is my
yourself? Nothing. That's the weird part. Oof. We're talking about psychology here. We tend to refer to them as good citizen engineers because, okay, we're spending and wasting an awful lot of money on that AWS bill. I'm going to make some changes. I knew someone once who knocked $10 million off their annual bill and wound up getting slightly dinged for it on their next review because they were not supposed to be focusing on that. They were supposed to be helping get something out the door faster. Were they wrong for doing it? I don't know. I don't have the context to say that. But you don't get points in corporate life for saving money before you're asked to save money.
So it's kind of a catch-22 kind of situation.
Well, much like all large systemic problems.
Yeah. So what you do in that case, you see it, escalate it. Yeah, escalate it up, because when it becomes something that the business cares about, great. Now you can focus on it. But it's close cousin to security. No one cares about security in much the same way. Wait, that's ridiculous. Who would ever claim that companies don't care about security? Well, most people, if you pay attention to what companies do and ignore what they say, because how do they invest in it? How do they prioritize it? I know companies claim to care about security because I read about it in emails I get from them right after they failed to care about security, and now my information has been scattered to the four corners of the world.
Does this impact the companies depending on size, or does it just impact everyone? Is it like directly proportional to the amount of engineers that you start to have in your company, or?
Size, yes, as long insofar as it is a proxy for complexity, because it's more to do with what is the organizational distance between the person who gets the bill and the person who can do something about it. In many of these large companies, particularly the regulated ones, they're not allowed to see the AWS bill. So you have 5 levels of indirect games of corporate telephone between the person that gets the bill and the person who wound up spinning up the $30,000 a day test cluster by mistake. When you don't get to see the direct consequences of what happens, it's what happens. That is how things naturally unfold. What's also kind of weird about the paradox of size is that if you look at through size through the lens of giant AWS bills, as I tend to, it's the smaller companies that have the interesting problems, because you're not going to have a misconfiguration that is accounting for a third of your AWS bill when you're spending $200 million a year on AWS, because people ask questions at some point about where is that $60 million a year going? It gets too big to ignore in the way that you can slip by when it's 20 grand a month.
I would say, though, I think there's certainly something to help both weirdly enough, not the very small, but the middle of this and the very high end of this. And it does come down to making it easier for people to actually understand the trade-offs between cost and performance.
Yes,
right?
always.
Like one of the absolute biggest problem right now is that from not even at an individual developer level, but like moving on up to like team or unit, whatever, there's extremely abstract, like what is the connection between what I'm doing in terms of like at a function level up to a architecture level of what the hell does like this mean when I do this, and then it comes out this other side as a bill, right? Like, where am I actually making trade-offs? Where can I optimize? What can I actually do to like change this balance of being able to like offload stuff? As a really trivial example, but the trade-off between storage and memory, right, and instance sizing, like serverless, true serverless.
More commonly, and when I view cost and architecture as being the same thing in cloud.
Exactly.
They are. More often than performance versus cost, what I see playing out is cost versus reliability.
Like when you do things the right way.
Do you need all of those backups? No, you don't, until suddenly you really do.
Yeah, but if you're doing things the right way, right, and you're doing like cross-region deployments and you're doing like cross-AZ stuff,
is that
like,
the
yes,
right
you're
way?
getting dinged for all of this. Is it the right way? That's a question that I can't answer for everyone every time.
Because it is a significant cost. And is that cost worth it? For example, I have an application that I use to write my newsletter, Last Week in AWS.com, every week. It is single-homed out of the Oregon region. Because if that region goes completely unusable for multiple days to the point where I can't write the newsletter, well, I have a different newsletter that I'm going to be sending out that week, and I can probably write that thing by hand. The requirement for that to survive an AWS regional loss does not exist.
I think there's like a common thread between the facts that both of you, Austin and Corey, brought in. The intent and the context in which your software is going to run is going to dramatically affect what you actually want to keep out of it and the storage and other elements that it uses. You can get rid of the logs. You can get rid of the redundancy computing resources, and you can save a lot, but there's also a cost on the other side.
I mean, I can bring this even more full circle to your API thing, and it's that you shouldn't trust everything you read online blindly, right? Like the only way you're going to know, like the reason Corey provides so much value, and I will personally vouch for Corey Quinn and Duckbill, right? Like I know people that use them, and I'm not here to plug them, but like they make a difference. And one of the reason they make a difference is they're human beings that are that have a lot of deep expertise and knowledge about their field of work. And they're able to go in and use the fact that they are human thinking beings to answer questions that don't have that do not fit into binary decision trees.
The twist is, though, that this is a deep fake. It's not really Corey, right?
Oh, yeah, exactly. I've had AI writing my jokes for years. It explains why they suddenly got better in 2016.
Hey-o. But again, same thing with like machine learning, same thing with API access, whatever. Like you can't replace the benefit of someone that knows what they're doing, effectively looking at your stuff and helping you make these decisions and helping you understand the trade-offs
We tried to build a SaaS tool at one point and shut it down a couple months later because what people wanted, or at least claimed to have wanted, was effectively Cost Explorer just done better. Well, AWS is going to improve its own tooling at some point, and we're competing against free. Doesn't work. What we've actually been building and been using successfully is what I consider power tools for AWS bill analysis, where if you give them to someone who does not have the context or understand what's going on, they're going to get themselves into significant trouble by taking whatever these things spit out and applying it blindly. That's not the purpose of it. That's not the point of it. This is the sort of tool that a professional who knows what they're doing could benefit from. But if you're not careful, it gets you in a whole mess of trouble. The first time you screw up severely and take down production by trying to save money, you're not allowed to save money anymore.
Like with observability, I think it's the same thing, right? You shouldn't be looking to observability tooling to kind of like answer these questions. Like the point of observability tooling shouldn't necessarily be help me find that, or have the computer find that 1% for me by using machine learning or some sort of AI model. It should be, hey, it's always going to take a human operator to really sift through all this and understand, based on a lot of context that a machine will never have, what's important at this given time. So you need tools that help you sift through all the noise, right? That help you, do what you need to do ahead of time to make sure that you have the right signal there and make sure that it's easily accessible, and help you have a model of the system so that when you do run into things caused by, very large distributed systems at, involving whatever APIs, involving whatever organizational scale, that you're able to come back, zoom out, and figure out where's the problem at, what's being impacted by it, and where do I need to go to solve it.
I think with this uplifting message and the fact we've gone full circle, I think it's a perfect point to move to our fourth fact. And the fourth fact for this episode is Phillips.
All right, so my fact for today is that you can write a semicolon at the beginning of a JavaScript line. Now, I'm not sure if you guys knew this or not, but there is a little bit of quirks with programming and programming languages in general, and I find that JavaScript makes definitely the top one of that list. They have a bunch of other really interesting, or I should say very confusing concepts that actually come into play. For example, null is not actually null in JavaScript. It's actually an object. Or none, which stands for not a number, is a number actually within JavaScript. So a bunch of contradiction there. And I kind of want to throw a question at you guys and see your opinion on this. Do you think mistakes like that or things that are implemented, are they done on purpose to build confusion for someone who's using the language? Or are they a result of poor implementation that just, sparked these unfixable quirks?
I wish that I could believe that people were competent enough to pull off these massive conspiracies that they're always accused of. It is such a next level beyond what I have witnessed from almost every actor of significant scale. No, it is almost certainly someone didn't envision a use case or an outcome. Back when I was one of the early developers behind SaltStack over a decade ago, well, I was convinced this was the configuration management system that was going to work for everything. And that lasted until I saw the first customer build something with it, at which point, you can create the iPhone. It changes the world, and hand it to someone. Like, this hammer is a piece of crap, and as they batter the thing to death. People are going to hold it wrong. That's the nature of the world.
I, on a contrarian opinion, think that this is completely a conspiracy by the lizard people, and Epstein. He was also involved. It is well known with together with Hillary Clinton and Trump together. But honestly, we kind of think in another episode we kind of touched on the roots of JavaScript, including its name being named JavaScript just to ride on the fame and the current and at the time current success of Java. Originally, it was called LiveScript. It's just a marketing scam to get you to use it. So they called it JavaScript. So when they created JavaScript, they didn't really have enough time to think about it as a language. They were just like, let's get this thing out the window. And as a result, a lot of the quirks, I think, came in, and they're sticking with us till today.
So now that we have all this unbound evidence, we can for sure conclude that JavaScript is a scam, and most of the programmers that do use JavaScript, which is a whole bunch in the world, are just This
is spoken by people that have never touched ActiveX in their lives.
and what's that?
Those people must be so happy.
It sounds like they are.
As a kid, I was on the VB script camp when JavaScript was just coming.
What could have been?
Yes, I'm not sure. I'm not sure what's worse.
Live desktops.
I think JavaScript's maybe what really comes against it when you value it down is it might be too successful for its own good. Like it wasn't built to scale this far.
It's too awesome to live. Yes, that is the problem with JavaScript. But no,
like,
it was a victim of its own success. It was not designed for the do everything with it use it was put to.
Right.
I mean, that's the extremely funny part about JavaScript and the rise of the browser as a runtime, right?
Mm-hmm.
That for certainly my entire childhood, from long back as I remember, the holy grail of software was write once, run anywhere. And we saw a variety of technical solutions to this, including obviously the JVM and also Microsoft's various attempts to either directly rip it off or indirectly rip it off.
Mm-hmm.
And what happened? Well, we have write once, run anywhere. It's called Chrome.
Mm-hmm.
And we've decided that the arbiters of this should be the world's largest advertising company, which
It's very interesting, actually. Yeah.
What do you think of WebAssembly in that context?
I think it's interesting. I think that WASM has a lot of really cool applications, and I'm not quite as... I mean, I know there's a lot of people doing like WASM on the server, which seems like intriguing to me.
Mm-hmm.
But the real advantage to WASM really does strike me as being able to write higher performance and more secure components for the browser runtime.
And no one cares about security. We already covered this today.
Look, a lot of people don't care about security, but in a variety of ways, the people that do care about security, like people that make operating systems and web browsers, at least some of them, like there is a security model for the browser, right? Like there is and it's a pretty okay one. There is a security model for the kernel, and it's a pretty okay one.
Mm-hmm.
So I think there's a lot of like productivity applications that we do that are written in some way through JS right now, even if it's not pure JS, like being able to replace a lot of that with WASM modules, I think will be helpful for ensuring that the browser remains the way that we run apps into the future.
So speaking of WebAssembly, I mean, WebAssembly is a big thing that's to do with my channel on YouTube, and how I kind of look at some people, the skills of others and then shine a spotlight on them. And I almost started to feel like WebAssembly is just there for other developers to be able to show off. And I don't know how much more benefits it actually brings, because I didn't really see it used in a very particular life scenario that would maybe benefit the company.
It's still kind of nascent.
I mean, I just think it's pretty new, and I think that it's not easy yet. And I mean, ultimately, we're talking about, like, just as one example, Lightstep is an observability tool, so we do a lot of charts and graphs, and boy, high performance rendering of plots with thousands or hundreds of thousands or millions of points in JS is a real exciting thing.
Mm-hmm.
So you can see the potential utility of being able to move parts of that entire pipeline into WASM modules running as workers rather than being done through JavaScript, through big bundles of JS. Like, and I'm not this isn't my job, so I don't want to like act like I've got all the answers, but I do think that there is, like, that's a thread that people should tug on more. I just don't think that there's necessary. I think it's a partially it is nascent, and partially like people don't care enough to put the work in. Like, you don't need to do the work right now. Like, there's enough tips and tricks and hacks, and we're so used to the poor performance of JS in general and browser-based apps in general that there's not like a huge demand for like, oh, go rewrite your whole thing in WebAssembly, because we simply don't need to. But as we need to, then it's great that it's there as an option.
Then as we need to, then AI will just do it for us, right?
Well,
or kill us, one of the two.
We'll already be moving to another simulation, or
you all will be in S3 paying bitcoins for your grandmother, JPEGs of your grandmother or something.
The memories.
Corey and I will be panhandling in front of the Salesforce Tower.
Oh, fantastic.
We'll be Organic but happy, maybe.
And thank you very much, guys, for joining us. Thanks, Austin and Corey. We appreciate having you here. It's been an absolute pleasure hosting you. And thanks, and have a nice day, everyone. Thanks for listening.
Next time. Bye, everyone.
Bye.
I think this is the perfect time to wrap up the show. If you liked this podcast, tell your friends about it. If you didn't like it, tell your enemies about it.
Cheers, y'all.